What's going on, guys? Today we're playing Calculus Integral Edition, and today we're doing definite integrals via substitution. So, we got this equation here, pretty impossible to do without substitution, and we're going to solve it. Okay, so let's start off by rewriting it. Alright. Now, while you're rewriting it, this is where you're thinking, like, what's my next move here? So, what you want to do here is pick the small the equation that's like the most inside, kind of like think about like chain rule, like the most inner function. You pick that one, and so you got 6x minus 5, and that's gonna be your u. So let's put it under here. U equals 6x minus 5, and now you're gonna want to differentiate that. Du equal, what's the derivative of this? It's just 6, right? So it's just 6 dx. This is actually where the dx comes from. Like, it's a big mystery, but they're related. All right, now you need a 6 to like actually put the du in to make it equal. Now you're gonna need a small loan. You're gonna pull a trump here, and so turn that 3 into a 6. Now 3 times 2, 6. How do I make a 2 out of nowhere? Well, 1/2 times 2 equals 1. Timesing anything by 1 is the same thing. So we're going to manipulate it. So what you want to do is put the 1/2 out. And then you're going to put the 2 times the 3. Now that's 6. You can write 6. I don't. I like to see how like it all like comes together. But if you want to, you can write that as a 6. Now that 1/2 stays out. It's out of the game. It doesn't do anything. Now that you have the 6x, you can actually turn this into u. Now the 6 dx is going to go away. It's just going to be replaced by the du. Now it's just going to be 1 since it gets replaced. And since u equals the bottom equation, we're just going to put u 3 dx as you were, du. Okay. Now you're going to say, well, we still can't do it. You're right. Well, let's rewrite it into something more manageable here. So 1. So since it's under it, you can just put u negative 3x. Perfect. Now you're going to want to integrate this or take the antiderivative. And then you're going to want to write these brackets here. Antiderivative of this is -2, -2, -2 right here. The du's gone. And then you're going to write, well, from now you're going to be thinking, why haven't I wrote anything here? That's because, well, these are still the same. But now you're going to have to find, once you replace these, you're going to have to find a different set of these. Now, I like holding off on this because, well, it's kind of simple, but all right. These are basically x's, right? From x equals 1 to x equals 2. We're going to have to turn it to u equals something to u equals this. And so you're going to want to use this equation that you have right here. You want to use the same one. Now, so 2, so it's going to be 12 minus 5. And that's 7. And then same thing for over here. So it's going to be 6 minus 5. So boom. So since that's the top one, so 7 from 1, 7 to 1, 7 to 1. I don't know. You can do it like while you're doing this, but I like to do it. I don't like to plug it in until I get to this. I don't know why. That's just how I do it. So you get the same answer. It doesn't change anything. Okay. Now you're gonna want to solve this just like any other definite integral. Now you're gonna want some space here, so I'm gonna just move my equal sign to here. Okay, and get the show on the road. And you probably already know. So this also equals f. So the well, let's write this somewhere else. So this integral here, it equals. Let me write it on here. Hold up. Let me move it up. Right. So that equals antiderivative of f 2 minus antiderivative of this. Well, we already found the antiderivative, but we haven't like put it in yet. That's what we're gonna do. That's the premise for this. If you don't know how to do definite integrals, so you take it, but it's not just like you plug, like you have to values here. So it's the bigger one, the one on top going first. Not the bigger one, but like the one on top. Not always the case that it's always bigger. Minus 2. Minus, don't forget the minus. 1 minus 2, negative 2. Okay. Okay. Now you're gonna want to put it on the bottom. So minus 2, that's just gonna be a normal 7. Minus 2. It's gonna go on the bottom, but we already know what that is. It's just gonna be minus 2, since it's just 1 squared. Alright. Now this is gonna be a doozy here. Times. Now, that's gonna be 49. 49 times 2, negative 2. That's just gonna be 98. Yeah, negative 98. Okay, we got that. So 2 times negative 98. So that's minus, one second, I can just do that. Okay. That's a big number. 2 times, negative 98. But you're pretty smart, so I think you know the answer is 196, negative 196. Find a common multiple here. You're gonna have to this times 188. That's a bit more difficult. Hopefully you know what that is. Just kidding. No one knows. I don't think you'll be able to find that unless you're pretty smart. Now, you can divide it. And so you're gonna times each side up and down by 49. So it's 1 over 19 plus 49. Now it's on the bottom. Let's not really at that. It's on the bottom, the thing. But you can always put it on the top, and then just be 48.96. Okay. Now we can half that. The way I like to reduce this down is to half-ize it, like make it half, until you can't make it half anymore since they're both even numbers. So half of that is 24. Half of this is 98. Half of that 12. Half of that 40 plus 49. And that I think is, I don't think that can, no, that's good. Yeah, okay, so think that's your answer. Let me make sure. Let me make sure here. I could have just been wrong. Oh, yeah, I'm right. All right. Well, good job. I'll do another one. All right, I'll see you guys later.